So in this video, I'm going to explain you how the hack CPU works and how basically the implementation of the hack CPU. So this is for task 9.3D SIT 111. So in this 10-minute video, I'm going to explain in two parts. So one is the architecture, and the other part is the HDL code. So let's get started. So for the architecture, I'm going to use this diagram to explain about each logic gates and how they interact with each other and how they make up the CPU. Now, before we move on to another, like to further details, we have to look at the extracted view of the CPU. So this is the extracted view. Basically, the instruction memory and the data memory, these two are the ones working together to produce inputs and fed it into the CPU. So for one of the input is called in-m, the other one is called instruction, and we also have the reset bit right over here. So these are the three inputs that goes into the CPU and produces four. One is called write m, the other is called out m, address m, and PC, which is a program counter. So this is the so this is the CPU, and this is what goes in, and this is what comes out. Now, if we look at the API, because we have to derive the API first before we write the code. So the API is so we have the chip name. We just name it CPU. This is the input. So we have the in-m, which consists of 16 bits. The instruction also 16, and we also have the reset, which is basically for restarting the current program. So we reset it. And this is the output. We have the output the out m, which is 16-bit. The write m, the address m. So this is a 15 address, and also the program counter. This is the API. Before we write the HDL code, we have to derive the API first. So this is the API. This is what we've got so far. Now, before we move on to the HDL code, let's just look just a little bit into the architecture, just to understand how each logic gate works first, and then we'll get straight into the HDL code and explain line by line. So let's look into each logic gates. So we can see that the ALU gives an output that is written to the data memory, and in order to do so, the ALU must specify a few things. So the first one is the content that the CPU is going to write into the data memory, and it is stored in the out m. And the second one is the address of the write operation in the data memory. Basically, this is where we want to put the content in the data memory. And the last one is the output that allows the CPU to write the content to the data memory, which is write m. And the program counter holds the next instruction, which will then be fetched and decoded and executed by the CPU. And now that we have identified the inputs and outputs, let's go into the HDL code. For the HDL code, I like to divide them into 4 parts so that it's easier to understand. So this is part 1. As you can see here, we have 3 different gates. We have the NOT gate, the AND gate, and the MUX gate 16. So these gates allow the CPU to function and perform specific operations. Firstly, there are 2 types of instruction coming to the CPU from the instruction memory. So these instructions are the A instruction and the C instruction. As you can see here, the first line determines whether the instruction is an A instruction. So this is an A instruction, and the opposite of A instruction basically is a C instruction. And the second line would be to determine whether the instruction is a C instruction. And then the last line, the MUX 16, the multiplexer is basically what it does is it selects the value, the instruction value or the ALU output. So either of those two, so the A instruction value or the ALU output, and should go to the A register. Okay, let's move on. Okay, so part two, we have an OR gate first. So the load bit in the A register would be 1 if either the A instruction or the ALU output is fed into A. And on the other hand, the A register is used to store the value that is fed into the A register. And it takes in the output A register in from the multiplexer and the output load from the OR gate as its inputs. And the output A out then generates the content or the value that is currently stored inside the register. And next we have the mux16. So another mux16. So this selects or A or M depending on the 12-bit instruction value. And then this AND gate here decides whether the ALU output is loaded into the D register. And then lastly, the last line, the D register loads the value of the D register from the ALU. Part three consists of the ALU. So the ALU computes a function on two inputs, which in this case would be the value that is stored in the D register and the value of either the A or M registers. And then it generates an output. So it consists of the control bits such as ZX, ZY, NY, F, and NO. So they're indicators of which functions is computed on the two inputs to produce an output. Whereas the output control bits such as the Z, OR, and G determines the properties of the result. And the following code, so there's OR16 and an AND gate. So there's two OR16. So the first OR16, they basically determine the address of the write operations, and the second one determines the content in the data memory. And the last one, the AND, allows the CPU to write the data to the data memory. Part 4 contains the PC, and which is also known as the program counter. We've covered this in in a few weeks ago. So the program counter is basically a register which contains the address of the instruction to be fetched next. And in this part of the HDL, the load bit of the PC is determined by the jump bits and the ALU outputs. So basically these lines of code determine the jump conditions and check the ALU outputs to see if the conditions are met. So for example, if the instruction is the C instruction and the conditions are met, the program counter will load the value that will ask the CPU to jump to the specific value or symbol. But if the PC is not loaded, then the PC is incremented, and by that it means moving on to the next instruction. So yeah, this is the last part, and as for now, it is the end of the HDL code, and also which explains as for now, I've already explained to you all about everything about the HDL code of the CPU. So this is comes to the end of my video, and hopefully I've fully explained everything according to the architecture and also the code behind it. Thank you for watching.